Welcome to the fifth and last video dedicated to CONSORT, the reporting guideline for interventional studies. We want to explain the methods to control possible differences between the groups and underline the properties of random allocation. Let's begin. We want to explain the methods to control possible differences between the groups and underline the properties of random allocation. Let's begin. Some variables are so important that you should not leave them up to chance. If the baseline severity is so important that any imbalance would compromise the interpretation of the results, we do not play it at random, we control it. Let's make a distinction between control and adjustment. Control is in the design, and adjustment is in the analysis. The first, pre-specified, respects the design, which preserves the statistical properties and allows to decide. The second, perhaps improvised during the analysis, might allow us to learn, but not to decide. Once the results are seen, deviating from the scheduled plan, wrote in the protocol, implies renouncing to confirm the hypothesis. Besides that, the method to control or to adjust are very similar. For example, defining homogeneous blocks of patients within which we compare interventions can improve statistical properties. Adding eligibility criteria is simple, but it reduces the population of potential beneficiaries of the intervention. Using information technologies allows the use of dynamic randomization, in which the probabilities of being located in a group depends on the previous balance, so that the differences between groups in comparison are minimized. Historically, we recognize Avicenna as the father of experimental medicine, Lindell as progenitor of the reference in the comparisons between treatments, and Hill for proposing randomization. Interestingly, this was the most ethical way to distribute the new intervention among potential candidates, since they did not have enough streptomycin, which was the experimental treatment, for all patients. Why is randomization so important? Why does introducing entropy allow these mushrooms to be made homogeneously? In this chart, the dispersion of the effect sizes obtained from the randomized trials is less than the dispersion from the studies with concurrent external controls. Simply, there should be expected less differences between patients and controls of the same center than if they were from different centers. The challenge is that statistical formulas only quantify the oscillation of random allocation. Analyzing these studies with concurrent controls as if they were randomized would mean underestimating their uncertainty, and this would lead to a bias that is called unpredictable, since it can go in any direction, a bias that statistical adjustment cannot counteract. But watch out, let's not complicate the control with unimportant variables, nor do we play randomly those variables that, if unbalanced, would make it difficult to interpret the results. And that's all for today. Well, no, one final advice, practice. Look in an intervention article as to what variables it controls and what variables it leaves in the hands of chance. See you in the next video.